All right, last video for function operations, which is our division. So you should have already covered the addition and subtraction and then the multiplication. Now we're looking at division. Division undoubtedly is the most difficult one because we add in something that we haven't had to do for the other three operations, and that is domain restrictions. When we have domain restrictions, we have to say what X is not allowed to be. So that's what a domain restriction is that we're going to put a restriction on our domain variable, which happens to be X in this case. Okay, so I'm super annoyed. You can see all my marks here because I'm just trying to get my different color to switch. And as you can see, it's on maraschino cherry and it's not working. It's very annoying. So sorry about that, but a domain restriction, what we want to do, restrictions, basically, in layman's terms, what X can't equal. And the reason why we have to have this in division is because we are not allowed to have 0 in the denominator of a fraction. So because we're not allowed to have 0 in the denominator of a fraction, and division creates fractions, we're undoubtedly going to have fractions for all our division problems, and therefore, if what ends up in our denominator has a variable in it, we have to make sure that it's not going to make that denominator 0. So we go along and we'll, solve the problems and simplify, but then we'll have to go back and say, okay, these are the values that would make our denominator 0, so we have to fix those. All right, so starting out, just like we did for the other operations, we're just going to look at an example. So I've got f divided by g of x. So f divided by g of x is the same thing as f of x divided by g of x. So I do f of x divided by fraction bar g of x. Now, this may seem like there's nothing else that I can do, but I want to remind you of something very important that you learned in Algebra 1 called factoring. And factoring is one of the most important skills in Algebra 2. So I always tell students the most important things are being able to solve an equation, being able to graph an equation, and being able to factor. They are huge, huge, huge. So if you look at this top part, both of these terms have things in common. They are both divisible by 3, and they both have at least an x to the second power. This has x to the third power. So that's what you called in Algebra 1 a GCF, or a greatest common factor. The number common factor is 3. The variable common factor is an x squared. So we put that out in front, and then we ask ourselves, okay, if I divided the 3x squared out, what would be left? So 30x cubed divided by 3x squared. Well, 30 divided by 3 is 10. X cubed divided by x squared is x. Remember that the rule is if you were to redistribute it, it should give you back the original, which this does here. So then I do the same thing. 9x squared divided by 3x squared would just be 3. On the bottom, this is a monomial, which means it's not going to factor. The reason why we needed to do this is because you are not, please don't do it. You are not allowed to cancel things that are separated by addition or subtraction. So do not cancel any terms that are attached to another term by addition or subtraction. You can only cancel terms that are separated from the next one by multiplication. So that's why we factor, because now this 3x squared is separated from this parenthesis by multiplication. This negative 3 and this x are already separated by multiplication. So that allows us to say, okay, well, 3 and negative 3, I can reduce that to just a negative 1 here in the bottom. I've got an x squared here and an x there, so that means that one of these x's cancels and goes away. So I just end up with x times 10x plus 3 here. And in the bottom, all I have is negative 1, which means simplest form would just be this guy. Now, I picked this one on purpose because our denominator actually kind of went away when we simplified. But that does not mean that you don't need a domain restriction. You are not allowed to have 0 in the denominator of a fraction ever. So even though the final answer doesn't have a fraction, there was a fraction over here, over here. We are not allowed to let this denominator equal 0. So some of you will just know what value makes that denominator 0, and you can just write it if you do. If you don't, then to find restricted values, set the denominator not equal to 0 and solve. So instead of setting equal, we set not equal. So our example here would be, my denominator is negative 3x. I set that not equal to 0 and I solve. If I want to get x alone, I divide by negative 3. 0 divided by negative 3 is 0. So I get x not equal to 0 in this case. So that is my restriction. That's the only value I get when I solve. So it's the only restriction. And normally I would put it right after, but I kind of ran out of room there. Whoa, sorry. Got all kinds of crazy going on there. So negative x times 10x plus 3 is the function answer with the restriction x not equal to 0. All right, I know that probably seems overwhelming. We're going to do another one. So we're going to do f divided by h of x. So f, same function, and this time I'm just going to write it in its factored form since we already factored it before. Divided by h, which is 10x plus 3. Now, you can see I picked these examples very specifically. The reason why I picked this one is because this 10x and this 3 are attached to each other by addition, meaning you cannot just hack off the 10x or hack off the 3. They're attached to each other. But because in this case, the denominator has the exact same thing, what you can do is cancel that entire term. So 10x plus 3 here is eligible to be canceled with this 10x plus 3 that's here because the 10x plus 3 in the numerator is separated from the rest of it by multiplication. So it's fair game. So when we simplify, that just gives us 3x squared for our function. But then we need our restriction. So again, if you just know it, awesome, write it. We're going to put x not equal to something. If you don't know what it is, do what we did here. Set our denominator, which is 10x plus 3, not equal to 0, and then we solve. So minus 3, that gives me 10x not equal to negative 3, and then divide by 10. And so we get x not equal to negative 3/10. And that is our restricted value in this case. All right, we're going to do one more here. And we're going to do g divided by h of x. So that gives us negative 3x divided by 10x plus 3. Now, as previously stated, you cannot cancel anything that is attached to another term by addition or subtraction. So I always get people on ones like this because they've gotten so excited about canceling things who try to cancel these x's. Yes, this x is separated from the negative 3 by multiplication, but this x down here is attached to this 3 by addition. So we cannot cancel those. There's actually nothing that we can do to cancel, which means that this is actually our final answer. We can't simplify. It has the same denominator that we had up here, which means it's going to have the same restrictions. So our final answer is our first step of work, and then we just add our restriction, and we're done.